Bakelite, a synthetic resin. So Bakelite was actually one of the first wholly synthetic plastics ever made. It was industrialized by Belgian-American chemist Leo Hendrik Bakelite. Physical properties. So Bakelite is highly resistant to heat and chemical change. It's not electrically conductive, it is insoluble, and it's extremely hard and rigid. So chemical composition. So Bakelite is a polymer. It's made up of two monomers, which is formaldehyde and phenol. So how is Bakelite actually made? So we first start off with, we have the phenol group, and we have formaldehyde right here. So what actually happens, it turns into, this is for 1-to-1 ratio, you get actually two results. Here the formaldehyde latches onto one of the hydrogens of the phenol group, and you actually get here a CH2 along with a hydroxide ion. And for Bakelite, following the final structure is actually the 1-to-2 ratio, where you have 2 parts formaldehyde and 1 part phenol. But before it actually turns into Bakelite, you need to go through one step with the 1-to-1 ratio, which is what makes Novolac right here. So this is the condensation part. The two come together, and the one hydrogen that's sticking out over here, right here, is exchanged out with the hydroxide group, and it turns into water. That's the product of a condensation reaction, right? And so this turns into Novolac, which is like a second step into becoming a Bakelite polymer. And with a lot of heat, pressure, and an acid catalyst, it turns into the full Bakelite. So here is the actual composition of it. So from here we see that it's only linear, and it would turn into a chain, right? But here we see it attaches to the bottom of that chain that was originally the Novolac. And the same things happen. You have water that come out right here. It's basically the exact same reaction, but at the bottom, like so, and then it turns into a CH2, and then the same happens over here. And now you've got, I guess, a scaled down version of what Bakelite actually is, because since it's a polymer, this entire thing just goes on forever as long as there's enough phenol and formaldehyde to create it. So why is Bakelite so hard? So Bakelite is known to be thermosetting. This means that after it's been molded, it turns into a solid, insoluble, unmeltable material. And so one thing is that the cross-links that make up Bakelite turn it into one unique molecule. Wait. The thing is, with polymers like Bakelite, it's sometimes hard to predict what might actually happen to them once they're formed. Although you could have one super molecule, it's more likely you're going to have multiple very large polymers that interact with each other. In this case, you could still have hydrogen bonding, which is still a very strong bond that would help in Bakelite's rigidity, alongside with its strong intramolecular bonds. And so in this sense, you could have some polarity, although it would make more sense in the individual monomers that make up Bakelite structure. Those monomers that make up Bakelite could exhibit polarity because of their asymmetry. However, since they're always mostly bonded together into huge molecules, you don't see too much of it. But hydrogen bonding certainly is part of Bakelite's strong and rigid structure. And so if you were to break that one piece of Bakelite, you'd just be snapping covalent bonds. So you can understand how hard Bakelite can be if, to break it, you'd be breaking covalent bonds. So because of these characteristics that Bakelite had, it had multiple uses. For example, It was widely used at first as an electrical insulator, and even today, because of its high resistance to heat and conductivity. You could also find it in places like home appliances and electrical car circuits for the same purpose. So because Bakelite was also a very durable material, it could withstand wear and was used in jewelry, like bracelets and rings of such. And utensils as well were made from Bakelite. You had a lot of jackets that came with Bakelite buttons, and even today, Bakelite is still used in the automotive industry for brake pads and as electric insulator.